Here is an example of a formula that could appear on your exam. In the past 5 years, I believe this formula has come up once. So they usually ask one of these questions per exam. So of all the formulas that we've had, some appear more than others, but this one I think has come up once. And they tell you that R stands for a regular investment. I is the interest rate per compounding period. So I'm going to put a little note off to the side that it is your rate It's a little bit confusing because there's two numbers that go into that number I, and N is the number of investments. And FV stands for the future value. So we're going to use this formula and solve a couple questions. And then we're also going to look at a calculator program that you have on your calculator that's going to be very useful for solving this as well. So, here's example 1. We're going to rewrite out that formula. How many monthly investments of $200 would have to be made into account paying 6% annual interest, compounded monthly, for the future value to be $100,000? So here's our formula. We have on that other page what each of those things stood for. Our future value is going to be $100,000. We're putting in payments of $200. Our interest rate is 6%, but remember that I was the interest rate per compounding period, so we'll change that 0.06 divided by 12 minus 1. Maybe I'll use square brackets. All divided by I, which is again 0.06 divided by 12. And I forgot the n right here. So we're trying to solve for that value of n. That n is in an exponent. How do we solve for things that are in an exponent? We're going to have to use logarithms. Now, this equation has more work to do than other equations that we've had so far. Because if we want to solve for n in the exponent here, well, we're dividing, we're multiplying. Maybe we want to try and see if first we could simplify. Can we simplify to get this part all by itself? What would we have to do? Well, right now we're dividing by 0.06 divided by 12. What's the opposite of that to get rid of that fraction? Multiply. So I'm going to start by multiplying both sides by 0.06 divided by 12, and this side by 0.06 divided by 12. The nice thing is here, they'll simplify away. And on this other side, 100,000 times 0.06 divided by 12 is 500. And now if so I have 500 equals 200, 1 plus 0.06 divided by 12 to the n minus 1. Can you see that if I divide both sides by 200, this will get rid of that 200. And I have 5 over 2. 5 over 2 equals 1 plus 0.06 divided by 12 to the n minus 1. I'm getting very close to getting that by itself. Last thing we're going to do, add 1 to both sides. Get a common denominator, so 1 is equal to 2 over 2. So we'll get 7 over 2 equals 1 plus 0.06 divided by 12 to the n. So we did all that work just to get that exponential thing all by itself. That's going to be nice because now how do we get those things out of the exponent? How do we get the variable out of the exponent? We have to take the log of both sides. And when we take the log of this right-hand side, does it make sense that your exponent of n can come out in front? Now we can divide both sides by that other log, and we get it all by itself. $251.17. Now that 251.17 is, n is the number of payments. And the question was asking how many monthly payments, how many monthly investments would you have to do? And since you're making payments per month, you would have to make 251.17 or 252. Because the last payment would just be a little bit smaller. If you think about how long that's going to take you, there's 12 months in a year. This is just over 20 years, almost 21 years. So if you started putting aside $200 a month now, in 21 years, you'd have $100,000. If we think about how much money that would be, $200 a month times 12 would be $2,400 a year. If you put $2,400 a year away for 21 years, that would be around $50,000. So you would put $50,000 away, but when you take it out, you would have $100,000. So that's how much the interest would be going for you. Now, at the top of page 431, I want you to write TVM solver, and we're going to learn how to use an app built into your graphing calculator that can solve this question quickly and easily and allow you to do all sorts of very cool mathematics very quickly. And of all the things that your graphing calculator can do, I would venture to say, well, for me, this has been the most useful thing that I've used in my day-to-day life outside of school. Because I use a graphing calculator a ton at school. But as far as things that have come up in my own life, this program is super helpful because you can use it to figure out how much money you're going to be spending on a vehicle. Or when you buy your house, how much your house is going to cost you. And having an understanding of interest rates can save you thousands and thousands of dollars in your lifetime. I'd venture to say even in the like $50,000, $100,000 you can save if you know how interest rates work and how they work. Well, but to begin with, we got to learn how to use this program. If you hit the apps button on your calculator, anybody not have a calculator here today? I've got a few extra. If you hit the apps button on your calculator, the very first one is finance. Push enter on finance, and the very first one is TVM solver. The TVM stands for time, value, money. When you push that up, a whole screen comes up with a bunch of different things. What we're going to do is we're going to describe at the top of page 431 what each of these things stands for. Starting at the bottom, the C per Y stands for how many compound periods per year. P per Y, that's your payments per year. FV stands for your future value. PMT stands for payment. PV is the present value. I is your interest rate, and it's not a decimal this time. And N stands for the number of payments. And for number of payments, usually it is your payments per year times by how many years. So your payments per year is lower down times by how many years that you have. We're going to put a special note at the bottom of this. The calculator needs some way to decide when you are giving money away and when you are receiving money, so that the way that they figured that out, anytime that you are, anytime you make a payment or a deposit, anytime you're putting money away somewhere else, in other words, taking it from your pocket and putting it into a bank, or from your pocket and paying the bank, that number will be negative. And so the opposite, anytime the bank is giving you money or giving you something that is worth money, those values will be positive. So if we look at our question that we just did, and we rewrite these things, NI, PV, PMT, FV, payments per year, compounds per year, and you are allowed to use this on the final exam unless the exam says solve algebraically. But if it's a calculator question and it just says solve, then it is accepted that you could use your graphing calculator in a program like this to solve for it. So for our question that we just did, we had monthly investments of $200. That would go in as a payment, and since you're taking your money and making a deposit, it would be negative. You want the future value to be $100,000, and that's how much you want the bank to give back to you, so that value would be positive. How many payments per year are you making? 12. How often is it compounded? Compounded monthly, so that's 12. And the interest rate is 6%. Was there any money in your bank account to begin with? Did they say anything about a certain amount of money to begin with? No. So we put 0 here. And when you're showing your work, if you were using this on a quiz or a test and you were showing your work, what you would do here is you would say what you're solving for. So this shows that all the blue values here are values that I got from the question, and I want to solve for that question. So how do you do that on your calculator? Well, it probably has a 0 to begin with. We're going to just keep it at 0. We're going to fill in everything that we know. So the present value is 0. We're making 200 payments. Those are negative. We want $100,000 in the end. Payments per year are 12. Compounds per year are 12. And if you look above your enter button in the bottom right-hand corner, you'll see there's a little word that says solve. So if we go to the one we want to solve for, which is n, and we want to get to that solve, so we're going to have to push alpha and then enter, it will solve for it 251.17. Notice that's exactly the same answer that we got before. A lot quicker too, and with a lot less chance of making a mistake. The other nice thing about this is you can quickly figure out different options. So in our example here, you're putting away $200 a month. So you might ask yourself, well, what would happen if I put $300 instead of $200? So I can quickly go and play around with numbers and say, what happens if I do $300? How much money would I have in the same amount of time? Again, now I want to solve for the future value. I can go alpha solve, and I'll have $150,000 as compared to $100,000. That's significant. Now, the place where you're going to use this outside of school, and you might have to save this video and watch it 10 years from now, or save it and watch it 3 years from now. Probably the first place that this could be helpful is if you're buying a vehicle, because that's going to be the first time that you're going to borrow money from a bank. So you're going out to buy a vehicle. How expensive is your new vehicle going to cost? $30. A $30 vehicle? Probably not. What do new cars cost? About 30 grand. So if you are buying something and the bank is giving you money to buy it, your present value is how much money they're giving you. And since they're giving you that money, it's going to be a positive number. So we're going to start by saying we're getting a vehicle worth $30,000, so we're getting a loan for $30,000 from the bank. How fast do they want you to pay it off usually? 4 years? 4 years, 5 years? So if we're going to say 5 years and we're going to make monthly payments, then the number of payments could be 60. Just a second. Interest rates for a vehicle. Have you heard any advertisements? 5%, 4.9. Usually they have a 0.9. Let's say this one is 4.9% interest. When you're buying a vehicle, how much do you owe the bank at the end of the loan? 0, right? Because you've paid it off. So what we've set up here is we've set up a present value as a positive 30,000 because they're giving you that money for your vehicle. We want our future value to be 0. We know that we're going to make monthly payments and that we're going to pay it over 5 years, so there'll be 60 payments. The value that we don't know is how much do we have to pay per month. So what you can do is you can put these values into your calculator and you can go, how much are my monthly payments going to be? Alpha, solve. And you can find out, okay, if I want that vehicle, it's going to cost me $564 a month. Okay? It'll also be able to say, well, if I paid $564.76 a month, and I did that 60 times, how much am I going to pay for that $30,000 vehicle? So I times it by 60. I'm going to pay $33,885. So I can calculate how much in addition is this vehicle going to cost me. So it's going to cost me an extra $4,000 almost to buy because of interest rates. That's how much extra interest I'll pay in order to get this vehicle. Now, $4,000 is a lot of money, but it's also not a lot of money, because the next major purchase that you're going to do after buying your car is buying a house. And buying a house is a lot more expensive than buying a car. we're looking at, instead of $30,000, we're probably looking at $300,000. Now, we're going to put that at 0. Now, clear that out. 0. Now, in Canada, when you buy a house, most often you're buying it over 25 years and you're making monthly payments. So in the end, 25 times 12, you'll make 300 payments to pay off your house. That's what most mortgages are set at. Interest rates for houses are usually less than interest rates for cars. You might be able to find something right now for 4% or maybe even less for 3%. But we'll start at 4. Again, they're giving you $300,000. We want to figure out how much our payments are because we want to pay off our house in the end. Our future value will be 0. By law in Canada, mortgages can only be compounded twice per year, so that's nice. That saves you a little bit of money. We want to see how much are our monthly payments going to be if we want to buy this house. So alpha solve, we're going to pay $1,578.06 a month. How much is this house going to cost us in total? Well, we would pay that 300 times. So I'll go here and I'll multiply this amount by 300 to find out. In the end, we're going to spend $473,418 to buy that house. How much money have we given the bank about? We've given the bank $173,000 worth of interest. That's a lot of money. Okay? Now the positive thing is a house increases in value. So chances are that 25 years later, your $300,000 house is probably going to be worth at least $473,000. So that's a good thing. It's not that you've lost that money completely, but you have given the bank a lot of money. So one of the things saying where this class can save you money in life is if when you're getting your first mortgage, you spend time looking around, because the biggest thing that's going to affect how much money you're going to pay is the interest rate. So you spend 3 days straight, 8 hours a day working, looking around for the best mortgage deal, and you find someone that offers 3.5% instead of 4%. And your partner says, "You're crazy, you spend 3 days on this? You could have been doing other stuff. You've wasted 24 hours of your life and you saved, what, 0.5%? How much of a difference can that really make?" Well, the nice thing about this program, you can play around with those numbers and you can see, what would that do? I saved 0.5%. Whoop-de-doo. You know, and you might be even able to convince a banker because you're like, it's only 0.5%, please. So what does that do? Well, now our payments are $14.97 a month instead of 15 something. How much are we going to pay in total? So I'll take this, I'll times it by 300. And now we're at $449. How much of a difference is that? It's like $24,000. When you think about those 3 days that you spent, 24 hours of work, you could be paying yourself $1,000 an hour for that work just to save that 0.5%. Because you save yourself $24,000 by just a small thing like a percentage. One thing you should do tonight is you should ask your parents or ask your grandparents, what is the highest interest rates that they've ever experienced? Because right now we are in a time where interest rates are really low. Historically, some of the lowest that they've ever been. But in the 1980s, 1990s, they were some of the highest that they've ever been in Canada. And it wasn't uncommon for interest rates to hit the high teens. like 18%. By the way, 18% is about what credit cards charge. So when you don't pay your credit card off, they're charging you high, high percentages. So if it was 18%, how much of a difference would that make? And you can see why people sold their houses in the 80s, because they didn't want to pay the interest rates, because they couldn't afford to keep it. So now, instead of paying $1,400 or $1,500 a month for that same house, you're spending $4,400 a month. And how much is that house going to cost you after paying that for 25 years? $1.3 million. So all of a sudden it doesn't make sense to buy your $300,000 house. Because if that interest rate was so high, you'd be paying $1.3 million for it. So you can play around with the numbers. You can look at interest rates. You can look at other things. Another thing, let's go back to a reasonable number, 4%. Here's your house. You're paying $1,600 a month. And this is true for most Canadians. You buy your house when you're younger. When you're younger, you can't afford as much because you're just starting your jobs. Whereas almost every job that's in, you get raises over time, more experience. Your wages will be higher 10 years into a job than they were when you begin. My salary is about double what it was from when I started as a first-year teacher. So it's significant. You can make a lot more money the more time you're working, but most people don't realize that when they're making more money, what they do is they spend more money and they keep their mortgage payments the same that they were when they started. What kind of difference would it make if instead they took some of that money and put it towards their house instead of spending it? And this is another place where you can save a lot of money. So for example, you're paying $1,578 a month. You've got a couple of years into your job and you realize we can afford to pay $2,000 a month. What difference will that make? So I'm going to put $2,000 in here. What's going to go down? What's going to change? The end. It's not going to take as long to pay it off now, right? So instead of taking 25 years, how much of a difference does that extra $400 a month make? Well, we solve for n, and we find out it takes off 93 payments. 207.5 payments instead of 300 payments. So you're going to have your house paid off in about 9 years less. How much is that going to affect the final amount if you increase your payment? So now I'm going to take this 2,000, I'm going to multiply it by 207.5. It originally was 473 at 4%. How much money did you save? And again, this is something a lot of people don't realize. They're making more money, but they don't necessarily put it against their debt. If you put it against your debt, that's $58,000. That's a lot of money that you can save. Plus, you'll be done paying it off 8 years earlier. So you're used to paying off $2,000 a month. 8 years earlier, now have now we have $2,000 a month more that we can do things with. So a very powerful program. Learn how to use it. Remember how to use it because it's going to come up and you can play around with things when you're buying your first vehicle and see what do different interest rates and how much is that vehicle going to cost. Play around with it when you're buying your first house so you understand how much you're paying. But if you take a couple things from this class, that if you forget the program, but you remember that your interest rate, getting that as low as possible is going to save you a lot of money. And Once you do start making some more money, if you decide to put that money against your debts, the quicker you pay them off, you will save a lot of money over time, especially on big things like a house.